Welcome back. We're moving right along up to 1.6 now. So we're going to talk about reciprocals a little bit before we get into the problems. You might have had some experience with reciprocals before. I know if you'd done Beast Academy before this course, then it was introduced in BA4 and then some more in BA5. But if you haven't done reciprocals yet or just need a refresher, then we're going to go over that a little bit. So if you remember back from 1.2, if you add 0 to any number, it doesn't change that number. You probably also knew that from before this course too. If you do 0 plus anything, then it doesn't change the number. You get the same x back. So we call 0 the identity for addition. And that just means that the identity means it's a number that you can perform the operation on and it won't change the original number. So for addition, that number is 0, because if you add 0 to a number, it won't change it. That's not the same for all operators. For example, multiplication, if you multiply by 0, you're not going to get the same number back. But we'll get there in a minute. So also from 1.4, we know that if we want to get back to the identity, so if we want to get back to 0, so let's say we have the number 6, and we want to get back to the identity. So we want to get back to 0. How do we get back to 0 when we're at 6? Well, we can add the negation. Because if you add the negation of a number, that brings you back to 0, right? It cancels out the number and brings you back to 0. So we know to get back to the identity, then you can add the negation. So now, moving on to multiplication, does multiplication have an identity? I just said it's not 0, because if you multiply a number times 0, you don't get the same number back. So if you multiply a number times something, then what do you have to multiply with to get the same number back? And that number is 1, which you probably already know. So if you do 1 times a number, you get that same number back. So 1 times x will just be x. All right, so that's pretty easy. But how do we get back to the identity? So if we have x, how do we get back to 1? So this can be solved with the reciprocal. You can also call it the multiplicative inverse, but reciprocal's easier to say. So the answer to that is actually going to be 1 over x. So 1 over x times x is going to be 1. And if you remember your fraction multiplication, you would know that to multiply this together, then you do x times 1, and it'd be x over x. And that, of course, would equal 1. All right, so let's assume that every number except for 0 has a reciprocal, because for a couple of reasons. If this is going to be the reciprocal, 1 over x, then you can never have 0 in the denominator. Also, to be a reciprocal, it has to be able to fill in this blank right here. So let's go ahead and delete this here. This equation right here has to be able to be filled in. So if x is 0, then there's no way to get to 1. We're gonna show that right here with problem 1.29. So what is the product of 0 and any number? And then using part A, explain why 0 doesn't have a reciprocal. We kind of just talked about that, but go ahead and see if you can come up with your own answer. All right, so again, if you do 0 times x, you're going to get 0, because 0 times any number is going to be 0. We talked about that in 1.3, and again, you probably already knew that before this course. And to be reciprocal, we need to find something to fill in the blank for this. So blank times 0 equals 1. What would be able to go in this blank? Could we do like 1 over a billion? You know, a bunch of zeros there. Would that be 1? No. How about we do, negative a billion, positive a trillion? No, nothing we can put here is going to work, because anything times 0 is going to be 0. So that means that no reciprocal for 0 can exist. All right, problem 1.30. Explain why the reciprocal of 1 is 1. All right, another fairly simple one. The definition of the reciprocal is what can you multiply with the number to get back to the identity, which is 1. If you're already at 1, all you need to do is just not change it. And we know that 1 is the identity. That's what we use to not change something. So 1 times 1 is 1. Or if you wanted to do the fraction format, the 1 over x, then you know that if you want to find the reciprocal for 1, then the reciprocal would be 1 over that x, which is 1. 1 over 1 is, of course, 1. All right, so what is the product of 1/2 and 2? And using part A, explain why the reciprocal of 1/2 is 2. Well, just from the previous problem, or a couple of problems ago, I thought we did 2. Maybe we didn't do 2. But we did something very similar, where we said that 2 times 1/2, which also looks just like x times 1 over x. Whenever you have the same number here and here, so here and here, that is the definition of the reciprocal. So that's going to be 1. So you know 2 times 1/2 is 1. So 1/2 times 2, 1/2 times 2, well, we know that multiplication is commutative. So if 2 times 1/2 is 1, then 1/2 times 2 has to also be 1. And we also just know how to multiply fractions, so we know that this would end up being 2 over 2, which would be 1. So a couple of different ways that we could do that to know that 1/2 and 2 is going to be 1. All right. Yeah, so if we were to fill in this blank here, so what times 1/2 is 1, then we would know that that is 2, right? That also means that if you haven't noticed already, then what is the reciprocal of 1/2? So the reciprocal of 1/2, again, like if you have 1/2, or you have this really, you have 1/2 and you want to get back to 1, what do you multiply with 1/2? And that is 2. So the reciprocal of 1/2 is 2. And the reciprocal of 2 is 1/2. So that means that the reciprocal of the reciprocal is back to the original number. So if you have 2, the reciprocal is 1/2, and then the reciprocal of 1/2 is back to 2 again. You can also write it like this right here. 1 over x is going to equal x. And always be careful, whenever you see x in a denominator, always make sure that the problem that you are trying to solve does specify that x will never equal 0. A lot of times you'll see when answering a problem, the problem will say you can assume that x is not equal to 0 or something like that. Or if you have something like 1 over 2 minus x or something like that, you can look for some wording in the problem that might say x, you can assume that x will never be 2, something like that. All right, so now the next one. What's the product of 5 times 7 and 1 over 5 times 1 over 7? And using part A, explain why the reciprocal of 5 times 7 is 1 over 5 times 1 over 7. All right, getting a little bit more tricky now, but still, you should be able to do this. Go ahead and give this a shot. Okay, so 5 times 7 times 1 over 5 times 1 over 7. Okay, we can use the commutative and associative properties to move things around a little bit, because you know that with multiplication and also addition, you can regroup however you want to regroup, and you can switch the order of things however you want to switch the order. So I see 5 here and I see 1/5 here, and I know that would be a reciprocal, right? You multiply those together and you get 1. So let's move those together. So let's put 1/5 times 5 together. And also we have 7 and 1/7. So let's put those together too. So there we go. 1/7 times 7. And then we just get 1 times 1, and that is 1. So this is a very quick way to just match up these reciprocals right here to know that this is going to be 1 times 1. All right, we know that these are reciprocals of each other because their product is 1. So that means we also know that if 5 times 7 we know is 35. 5 times 7 equals 35. So that means we know that the reciprocal of this has to be 1 over 35. So we know that this is true, right? So 1/5 times 1/7 has to be 1 over 35, or 1 over 5 times 7. So, and this explains this a little bit more, the reciprocal of a product. So if you have a product x times y, then the reciprocal is going to be 1 over xy. So it's a product of -8 and negative 1 over 8. So we're talking about negatives now. Using part A, explain why the reciprocal of -8 is -1 over 8. Okay, so we have -1 over 8 times -8. So we know a negative times a negative equals a positive, and we could show that if we wanted to go through that again. I could do that real quick. -1 over 8 is the same thing as -1 times 1 over 8, right? Times -1 times 8. Right, so we know that these are equivalent. This right here and this right here are equivalent. All I did was extract that -1, and now we can regroup. We can put the -1 times -1 together, and we could put the 1/8 and our 8 together, and we know that these are going to cancel out and be positive. Negative times a negative is a positive, and that's going to leave us with 1/8 times 8, which is going to be 1, of course. So we have right here. So using part A, explain why the reciprocal of -8 is -1/8, because when you multiply them together, you get 1. So that's the definition of a reciprocal. And that's it. We got through reciprocals. That felt pretty quick. So go ahead and do your 1.6 exercises if you have the textbook, and I'll see you next time for 1.7.